Hi, so welcome to the first video for engineering data analysis, and for today we're going to stroll a little bit on the week 1 topic. So for week 1 topic, we're going to talk about the introduction to engineering data analysis, and we're going to learn about obtaining and collecting engineering data. Okay, so for this video, you're going to learn how to identify the role of statistics. Okay, specifically statistics that we use in engineering problem solving process, because back in your high school, I'm sure that your statistics is a general statistics. Okay, so you're not intentionally using stat to produce or to solve engineering problems. Okay, so we're going to learn about engineering problems here. Also, you're going to learn how to explain, or you can explain how variability. Okay, when we talk about variability later, you will know affects data collected and used for making engineering decisions. And also, students can identify the different methods and engineers use to collect data. Okay, so for example, this one, for this topic, we're going to stroll a bit, okay, on stat. So he says here that stat is a science that helps. So it's not a mathematics really. So statistics is a science that helps us make decisions and draw conclusions in presence of variability. Okay. Okay. So first word that we're going to talk about here is variability. Okay. So what do we say, or what does it mean when we say variability? Okay. So let's continue. So for example, civil engineers working in transportation field are concerned about the capacity of regional highway systems. So of course, because civil engineers design road networks. So a typical problem would involve data on the number of non-work, home-based trips, and number of persons per household, and the number of vehicles per household. And the objective would be to produce a trip generation model. Okay, so a trip generation model, we're not going to discuss more about that one. But in essence, okay, so in essence, what the example is trying to say here is, and a civil engineer needs to determine if the road network can 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 accommodate the number of persons, the number of vehicles that travels along with it. Okay, so what does it mean here? Okay, so very good explanation is this. Every day, okay, every day a single person travels. Okay, so he travels going to work. Let's say that you only have linear. So it's when I try to say is that home to, let's say, school. Okay, so this is you and school, and then you're going to go back again. Okay, so what we're trying to say here is that there are times that you are not going to school, you are going somewhere else. And sometimes you are also not going to school, but you're only staying at home. So the idea is that variability is normal in a way that nothing is constant. Okay, okay, nothing is constant. So when they say nothing is constant except change, that's a very vague way to say it. So how can we design? How can we design road networks such as this? So one one good example is that using regression methods. So regression analysis. So we're going to learn also regression analysis on the last part of the engineering data analysis here. Okay, so here simple linear regression and correlation. So we're going to learn about that one. So let's go back here. So in order for us to design a better road network, we have to anticipate. Okay, but sir, again, the number of people that is crossing or that is using the road is changing. Okay, for example, this is Monday, this is Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so and this is, yeah, that's the x-axis, and the y-axis is the number of person. So this is the first step, this is the first step you're going to do. So let's say that you're going to count how many people are traveling in that particular road, okay, in that particular road for, let's say, a given one day. So let's say that um, you're going to use orange here. Let's say that, sir, Monday we counted the total number of the vehicles that passed through that road to be 200. Okay, let's say that's 200. Okay, note here, that 200 is composed a variety of vehicles. So that 200 may be bicycle, that could be a motorcycle, that can be bus, that can be car, that can be truck. Okay, but what you're saying, what you're trying to say here is regardless of the vehicles that is using the road. Okay, because if you're going to make an individual inventory of each vehicle, it will be difficult because you will not only arrive with just one data. Okay, so for example, I'm going to show you. So let's say I'm going to use orange for bicycle. Okay, and then you're going to use, let's say, green for car, then you're going to use light blue for motorcycle. So we're trying to say here is that there are many people who are using motorcycle, then the number of people who are using car, and then there are few people who are using bicycle. Okay, so this is the number of person, ha, number of person ito. So pataas yan. Let's say 200. Let's say this, sorry. So let's say this is 200, this is 100, and this is 50. Okay, so that's on Monday. So let's say Tuesday. So you found out that there are only 180, and for bicycle, for motorcycle, you have increased number. You have, let's say, 150, and then for bicycle, you said that it's just same 50. Okay, and then the next day, bicycle went 50, and then still the same. Thursday, 51. Let's say 51, and then 49, and let's say 49 again, and then 50 again. So bicycle, and then we noticed that the number of motorcycle that the car, sorry, the car is increasing like this, and Thursday, and then Friday, and then Saturday, and then Sunday. Okay, and then that's for the car. And for the motorcycle, let's say that the motorcycle is like this, and then like this, then like this, then like this, then like this. Okay, so sir, anong ibig sabihin yan? Okay, so the only way for you to get a very good implication of the data here is to do linear regression. Okay, so what's linear regression? So linear regression is kind of like this. Okay, so you're going to collect the data, and then you're going to create a straight line. So it's basically an average of all the data sets. So you're basically making the average of all sets. Okay, so going back, so let's say this is the linear graph. Then, and for the green one, okay, then, and for orange, which is bicycle, okay, it's just like that. So remember in your analytic geometry that a particular line with the coordinates can be plotted by its equation. So for example, this one. So again, this has an equation. So y is equals to mx plus b, and this green line has an equation y is equals to mx plus b, and this orange has a line y is equals to mx plus b. So, sir, what's the point of these equations? So these equations can be used to predict, okay, to predict the number of bicycle, predict the number of cars, predict the number of motorcycle that passes in any day, okay, in any day. So it means to say that you have a formula or an equation to determine how many of per each category drives along the highway. Okay, so this using this formula, so that's the line regression equation. So what I'm trying to say here is that, for example, y is the number of people because that's a y-axis, and x is the number of day or any particular day. So let's say x is 1. So basically, when you have this equation, you already have the y-intercept, and you're also going to arrive with the m, with this slope, because the slope is basically the change of y over change of x. So that's basically the number of day divided by the number of people that you are going to expect. So again, this already has an equation. That is already have a value. Okay, that's easy. You can learn that one on the regression analysis on the last parts. So that's how you're going to do it. So the statistical technique called regression analysis can be used to construct this model. Okay, so the trip generation model is important tool for transportation system planning. And take note, this regression analysis is already a part of statistical analysis, or one of the statistical tool that you can use. So obviously, obviously, if you want to have a problem in your term paper, you can use regression analysis, which is very easy. Okay. Okay, so I'm not going to talk about this one. So right now we're going to talk about the engineering method and statistical thinking. Engineering method. Okay. So let's say that this is an engineer, and you have a hard hat. Okay. Yeah, let's say an engineer wearing a hard hat. Okay. So, an engineer is someone who solves problems of interest to society by efficient application of scientific principle. Okay. So, when we say engineer, an engineer is the one who solves problems. Okay? Solve problems. So, an engineer is expected to be someone who can solve problems. Okay? Not just solve problem, okay? Not just solve problem, because marami kasing problem na, okay, you can do this, but the question is it efficient? Okay, well, it's working. Any kind of solution to a problem can work, but is it efficient, or is it cost effective? When we say cost effective, sulit ba, or nakatipid ba ako? Ganon. So, again, engineer accomplish this by either refining an existing product or process, or by designing a new product or process that meets customers' needs. So, the engineering or scientific method is an approach of formulating these problems. The steps in the engineering method are the following. Okay, so, Sir Ikal, meron palang steps. Yes, there is a step. So, what's the first step? So, first step is to develop a clear and concise description of the problem. So, for example, let's say you have a motorcycle. No, wait. Let's say that you have a easy lang let's say you have a okay, so let's say you have a gas burner, yung kalan. Okay, let's say you have a gas burner, Okay, and this is your stove, this is your valve, this is your stove or gasol. Okay, so let's say that you want to cook fried fish. This is your pan and this is your fried fish. Okay, it's a fried fish, and you try to turn on the stove, but it does not work. So there's no fire coming out of the stove. So what's the problem? Okay, so what's the problem? So that's step number one, is to develop a clear and concise description of the problem. So the problem is that the stove does not work, or there's no fire coming out of the stove. Okay, so step two, identify at least tentatively the important factors that affect this problem or that may play a role in the solution. Okay, so in order for you to understand the problem, you have to understand the key elements or the parts of of the stove. Okay, so we're going to highlight here. So the first part of the stove is of course the stove grill itself, and then we have the control knob, we have the hose, we have the gate valve, and we have the tank itself. Okay, so we have 1, 2, 3, and 4. Now you have to ask yourself, are these all are these all components have the problem? Okay, so step 3, so propose a model for the problem using scientific or engineering knowledge of the phenomenon being studied and state the limitations or assumptions of the model. Okay, this is very tricky because we are intended to use these steps for a very one of the, I mean, some of the problems, but for an electric stove we don't, for a stove like this we don't really have to propose a model for the problem. Okay, you don't really have to propose a model, because obviously all you need to do is to check all the parts. Okay, so propose a model. Okay, so the model is like this. So gas stove, pass through the hose. Oh no, pass to the valve. Gas stove, then valve, then hose, and then no, and then stove, and then we have the igniter. Okay, the igniter. So this is the model. So you have the gas, goes to the valve, and the valve is connected to the hose, and the hose is connected to the stove. Now, the igniter here is a separate part because it is not part of the whole hose thing. What I'm trying to say is, hindi dumadaan ang gas dyan sa igniter. Okay, kaya nakahiwalay yan. So, ibig sabihin, ito lang yung nakabuo. Gawing ibang kulay. Okay. So, this is the separate part. Okay. So, this is the... So, there we have two components. So, basically, we have two major components. We have one, which has the gas in it. And the second part is the igniter. So, that's the step 3. Okay. So, you already have a model for this one. So, number 4 is conduct appropriate experiments. Okay. So, experiment. Number 1. So we go, there are a lot of varieties or technique that we can do. We can either start from gas to valve to hose to stove, or we can start from stove to hose to valve to gas. But for me, the easiest part for you to know is to go to the source. So where does this fire begin? So we go to the gas. Okay, so check natin yung gas dito. Pipitikin natin kung may laman. Okay, may laman. Okay, so check. Walang problema ang gas. So may laman. Then we're going to check the valve. Is the valve turned on or is the valve turned off? Well, the valve, let's say the valve is on. So, okay, no problem with the valve. And then we're going to check the hose. Is the hose properly connected to the valve and to the stove here at the ends? Or is the hose, does the hose have any holes? So you're going to check the hose. So let's say that the hose is okay. And then you're going to check the stove, the burner here, the burner. And you found out that the burner is okay. So stove, burner, okay. Now, the last element that you're going to inspect is the igniter. So you're going to check the igniter on. So, merong spark? Wala. Oh, okay. So the problem is the igniter. So that's it. That's how you really do in engineering problem solution. So you're not going to panic. You're not going to try to open an igniter again because probably, okay, probably it's not the igniter that is a problem. Maybe the valve is off, or there is no gas. So you have to think logically. So what we're trying to say here is that you think logically. Okay, so that's step 5, and number 6 is manipulate. Okay, we already skipped the model, so we already have 6. So you already manipulate the model. So you already so you already manipulated the model in a way that you already know the solution to the problem. So we already manipulated here. So we check the gas, we check the valve, we check the hose, we check the burner, and then we manipulated the igniter. So it's okay. And then we already conducted number 7, which is conduct an appropriate experiment. And then number 8 is draw conclusions. So the solution is, let's say that the problem is the igniter. Let's say that the igniter is not working. So let's say it's not working. So what would be the solution? Of course, the solution is to replace the igniter. Plain and simple. Or if you can't use an igniter, use a posporo or match. Use a match. So that's it. So this is basically the model. Okay. So this is the engineering problem solving method. So first one is to develop a clear description. Again, the problem is there's no fire coming out of the stove, and these are the 3 key elements. Now we're going to highlight on these 3. So these 3 is basically the essence of STAT. Okay, you identify the factors, you propose or refine a model, you conduct experiments. So that's the engineering way. So hindi na nahuhuli na lang yung manipulate, because you're going to manipulate if there is still something wrong with the model. For example, this is your model, right? So let's say that even if all of the elements here are okay, they're all okay. Now, there's no problem with the igniter, there's no problem with the stove, there's no problem with the gas, there's no problem with the hose, and then the stove, okay? And then you said, finally, so what's wrong? I mean, what's wrong? Now, there's probably there's something wrong with the model itself. So probably, maybe, okay, maybe the valve is not really connected to the hose. Or let's say that hindi, ang nangyari kasi dito, alam ko na agad ko na yung magiging model eh. Alam ko na eh. So what if hindi ka familiar sa mga stove, di ba? So kapag hindi ka familiar sa mga stove, syempre mangangapa ka pa. So for example, gas, tapos sinabi mo hose, tapos sinabi mo na valve, tapos sinabi mo na, alam mo yun, let's say na walang hose dyan, tapos diretso ka na agad sa valve, gas, valve, and stove. And then kahit okay lahat ng elements na yan, kahit okay yung gas, okay yung valve, okay yung stove, okay yung igniter, ano yung problem? So hindi pa rin gumagana yung stove. So that's where you're going to manipulate the model in a way that you're going to inspect again what's wrong. I mean, mayroon bang kulang? So then you can confirm that there is a problem with the model, and then you're going to correct the model, and then tadan, gumagana na yung stove. So congrats, meron ng apoy. Oh, yan, apoy na. Yeah. So that's it. Okay? So the field of statistics deal with the collection, presentation, analysis, and use of data. Okay, so you're going to present data. You have to analyze the data and use this data to make decisions. Okay, I think that's one of the problems in current problems today. We just we just know how to collect. We just know how to analyze. Yeah, we know, sir. We know how to collect data. Of course, we collect data. You survey. Of course, sir. We can do analysis, sir. It's easy. We were taught in high school how to analyze our survey. We know how to analyze a survey. Let's say the survey we use ANOVA. And then, okay, so if you know how to use ANOVA, how to interpret the data, how about, do you know what does what the survey means? Okay, so you did the survey. Can you interpret the data, or do you know what does it mean? Okay, I think for me the easy, I think for me the most important aspect in the field of statistics is that you use the data. You analyze and use the data to make decisions and solve problems and design products and processes. I think for me that's the most important, because you can collect data, and you can process data. You can present data, but what can you do? What can you do about this data? So if you cannot use data purposefully, okay, when you say, if you don't have a purpose for your data, so what's the point? You have to have a purpose. You have to have a purpose for your data. That is why we engineers are solving problems. Okay, we solve problems because that's our purpose. Okay, I hope that's clear. Okay, so going back. Okay, so basically what we're saying is statistics is the science of data. So science. What is science, by the way? Science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world. Okay, let's break down a bit. Systematic. Okay, so when we say systematic, it has an order. Okay, done acting according to a fixed plan or system or methodological. Now, again, that's why we try to say that I mean, statistics is the science of data, because there is a process. First, you collect data, and then you collect data, and then process data, then you analyze data. Then after you analyze, you present data, and then conclusion. You can't have a conclusion without collecting and processing the data first. That is why that is highly encouraged for you to collect data first. So to understand, you have to understand really the problem. So you have to understand it before going to conclusion, because again, collecting, processing, analyzing, and presenting, you already skipped 1, 2, 3, 4. You already skipped 4 processes. So please, okay. Now, go to the variability. So statistical methods are used to help describe and understand variability. Now, kanina pa natin napapansin yung variability, di ba? Now, this is a good example of variability. Temperature in Najongan. Let's try this one. So, as you can see here, the temperature in Najongan is changing. Maybe today is 28, later in the afternoon it's around 29, 29, 28, 27, 27, 26, 26. Now, the temperature in a given day changes. Hindi lang nga given day eh. Every minute, every second, nagbabago yung temperature. Mga slight differences. So, even if, 28.1, 28.0, 28.2, 28.2, 28.1, 28 point, let's say 3, 28.45. So let's say this is at time is equals to 0, and this is 1, 2, 0, 1, 0, 1, 2, 3, 4, 5, 6, and this is 6 seconds, right? So let's say every second you are changing, the temperature reading is changing. So after 7 at 7 seconds, hindi na siya 28.45. Let's say 28 na siya. You know, so ano ba talaga? So the question is, what kind of data are you going to use? Right? So that's the reason why we have stat. Because we have to understand that variability or changing, there are already fixed changing. So what I say is this, change is really constant. It's changing. So especially if you are in the natural world. Okay, it's natural to have a change, you know. But mga change is coming. Huwag ka maniwala dyan. Okay, so we all encounter variability in everyday lives. So, and statistical thinking can give us useful way to incorporate this variability in our decision-making processes. Okay, so what does it mean? So let's say that this is temperature per second now. So what can you do? The easiest way for you to do this is to sum up and then divided by the total number. Okay, so get the average. What I'm trying to say is that you get the average. You get the average. That way, when you were asked for t is equals to 7 seconds, when you're asked about what's the temperature, what could be the temperature, well, the temperature might be, you know, this is the average temperature. So you can say it's 20, maybe the average for this one is 28.1. Okay, when you say it's 28.1, okay, this is what you say. This is what you say. But let's say that the actual reading is 28.12. Okay? So, hindi na masama. Hindi na masama. So, yun ang ibig sabihin. Okay. Now, we also have sources of variability here. The sources of variability, ang point lang naman dyan is that in a system, okay, in a given system, let's say you have a table, okay, and let's say may naglagay ka ng pagkain dyan, or let's say naglagay ka ng cake na may candle, okay. So what we try to say with the sources of variability here is there are a lot of factors that can affect the cake on top of the table. So, pwedeng air, naka-apekto sa cake, pwedeng temperature, naka-affect sa cake, pwedeng pressure, naka-affect sa cake, pwedeng toxins, like yung mga lason, mga ganon, mga dust, mga particles, etc. Okay, so these factors can lead to the change in the cake. Pwedeng ang ibig ko sabihin is pwedeng maging mabilis ang pagpanis, pwedeng mabagal ang pagpanis. Okay, yun ang gusto kong sabihin dito. Now, if you want to eliminate all the possible sources of variability, what can you do? What are you going to do? Okay? Let me think. I'll let you think for 2 seconds. Alright. So, in order for you to limit or to eliminate possibly the sources of variability, ipasok mo yung cake na yan sa loob ng isang container. Okay? Ibig sabihin, hindi na makakapasok ang air, hindi makakapasok ang toxins, walang pakialam ang pressure, wala din pakialam ang temperature sa loob. Tapos, sabihin pa natin, ipasok pa natin siya sa loob ng ref. Okay? So, that's how you're going to limit variability. You make a controlled environment. In this case, you put the cake inside a container and then put it inside the ref. So that's the control environment. When we say control environment, we can only have one factor that have an impact on the cake, which is obviously the temperature. Kapag pinasok mo yung cake sa loob ng ref, yung temperature lang naman yan. And what can you do? And does this address the problem of variability? Yes. Why? Because you can control the temperature of the ref. Pwede mo na i-control yung temperature ng ref, kaya wala ka ng problema sa sources of variability. So it means to say, okay, proceed lang ako. It means to say that you can effectively eliminate all of these things, and now you can finally say, okay, based on our data, at t is equals to 3 days, okay, let's say this is the quality of your cake, and this is the time in days. Let's say at third day, yung quality ng cake mo, yan na. So, hindi na siya 100% kasi sabihin mo, medyo nagbago na yung kulay ng cake. Tapos after 3 days ulit, 6 days. At ika-6 day, medyo bumaba ulit. Kasi medyo yung amoy medyo bumaho na. Tapos ika-9th day. Tapos ika-12th day. Then, you can have this line again, regression line, that gives us the equation mx plus b, which can give us a forecast or interpretation, or we can forecast how many days, okay, the rate of change, okay, the rate of change that the cake na mabubulok. So let's say, doon natin makukuha yung tinatawag na shelf life. So, shelf life, pag pinasok mo sa loob ng ref. Okay? So, kapag nagkaroon ka ng cake na, let's say, kakabili mo lang ng cake bagong gawa, dahil alam mo na dahil gumawa ka ng study tungkol sa mga cake, okay? So, gumawa ka ng study tungkol sa mga cake, nakuha mo yung secret formula para makuha yung shelf life. So, ibig sabihin, yung Y na yan yung shelf life. So, shelf life is equals to mx plus b. So, panakita ko yung cake na yan, ito yan. Ang average shelf life talaga niyan ay yan. 7 days. So, ganun. so yun ang point. Okay? So, that's how you do statistics. That's how you use the regression. That's how you use statistical tool in making predictions. Okay? So, you can predict. So, that is if you're going to control the cake inside the ref. Now, this is a different scenario. A cake on top of the table, exposed to all other factors like air, moisture, temperature, pressure. Now, is yung shelf life mo ba equals to 7 days ay applicable pa rin dito? Obviously, hindi na. Because yung shelf life na nakuha mong data is already obsolete kasi meron ng air, moisture, temperature, and the temperature is changing. Again, napansin nyo kanina, di ba? Yung temperature sa isang araw nagbabago. Unlike noon, sa loob ng ref, fixed lang yung temperature. So, obviously, hindi na applicable yung 7 days. So, you make a study again. You make a study that is going to focus on that is going to understand all the variables here. Okay, but good luck. Kasi ang dami factors yan. So, good luck na lang. Kung matatapos mo yun. Okay, so that's it. Alright, so I guess na-satisfy na natin yung yung requirements. Okay, so okay. Dito na tayo sa different methods in collecting data. Alright, so collecting engineering data tayo. Okay, so in the previous section, we illustrated some simple methods of summarizing data. So we have retrospective study. So we have 3 kinds of study. So we have retrospective, we have observational, and we have designed experiments. So let's talk about retrospective. Okay? So, historical. So, retrospective study is a historical process data archived over some period of time. So, it means to say that this retrospective study is a kind of a study wherein you're going to take into consideration the time origin, or let's say the time which is previous, and then you're going to collect data from the previous time up to the present present time. So these are the data that you're going to collect, and those data you will use to make a conclusion. Okay? So ito lang naman 'yon, so retrospective study. So kailan niyo ba magagamit ang retrospective study? For me, magagamit niyo ang retrospective study sa if you're going to make historical data. Useful ang historical data if you want to predict the future. Okay. So basically, if you want to predict the future, hindi pasok dito yung sa loto, ha. Hindi. Hindi. Hindi ganoon. Yan yung mga tinatawag natin mga probability na. Hindi, you can't really predict such things. You can only get the probability. Okay, but you cannot predict. Okay, so let's say that you can predict, historical data, the number of students. Okay, so let's say the number of students is increasing. Sorry. Sorry, mali. This is the number of years. This is the number of students, population. And then, as you can see, it's increasing. So, let's say na pinanganak ka dito, let's say 2002. Okay? So, dito ka pinanganak, di ba? Okay, so what historical data or retrospective data here is, kung pinanganak ka dito at dito ka magka-college at gagawa ka ng study at year 2021, ito lang yung makukuha mong data, di ba? From 2021 and beyond, habang buhay ka pa. Okay, so retrospective data is you're going to consider all of this data from the previous years. Yun lang. Yun lang. That's retrospective data. So observational data, on the other hand, is, let's say this is your population. Okay? Observational data. So let's say this is your population and you have some Chinese people. And these are pure Chinese people. So observational study, so where calls Chinese peeps. Okay. And then you, let's say you're going to play the role of the god. And then you're going to say, okay, what will happen if we're going to introduce one Filipino? What will happen to the community of Chinese? So we're going to make a going to observe, okay? Going to observe the interaction of the Chinese people with the Filipino people here. You're going to get the data. So what will happen? Chinese one bump into the Filipino people. What is the impression? Is the impression disgusted or what? Or surprised? Okay, and then the second person is also surprised. The third person is also surprised. So let's say that surprised. So we say how many people are surprised. So how many Chinese people are surprised to see a Filipino people? So let's say that there are 3 out of 10. So basically that's 30%. So you say 30%. Wow, 30% of the Chinese people were affected, surprised by the Filipino people. So hindi lang yan yung data, no? You can do a lot of things. So that's observational data. That's observational study. So minsan ginagamit dyan yung mga survey, yung observational study is yung surveys, yung mga experiments minsan, yun. Kasi if you are going to do experiment, you're not considering the previous times na hindi ka na gumawa. For example, experiment ka ngayon, obviously, ngayon lang yung makukuha mong data, hindi mo makukuha yung previous na data kasi hindi ka pa nag-experiment doon. That's observational study. Okay, last one. Design experiments. Now, what are design experiments? So, a design experiment is just like yung cake sa top ng table kanina na pinasok mo sa loob ng ref. So that's design experiments. It's going to be a design experiment because you are already, okay, you are deliberating or purposefully changing the control variables of the system or process. Now, let's make a good example. Now, i-improve lang natin yung cake kanina. Okay, level up lang ha. Let's say ito yung loob ng ref. Tapos, let's say na nandyan sa loob yung cake. No? Anong gusto ng cake? Kulay pink. Okay. Let's say nandyan yung cake sa loob. Okay. Again, pinasok mo yung cake sa loob ng ref because you want to eliminate noise. When we say noise is yung mga other factors that might affect the cake. Okay, that could be those factors can be, you know, again, air, temperature, moisture, because again there are variability. So the reason why you put the cake inside the ref is because you want to eliminate variability. Now, the only thing that you can control inside the refrigerator, okay, is of course, the temperature. Now, this is what makes the experiment really interesting. So let's say that you set the temperature at 20 degrees Celsius. Then you're going to collect the data. Same lang din kanina yung time, yung days. Okay? And then yung quality. Then makukuha mo rin yung slope. Okay? Okay. So let's say wait. So let's say that you're going to use red for 20 degrees Celsius. So this is the line for 20 degrees Celsius. And then let's say you make another study. Let's say sir, gawin nating 15 degrees Celsius. So ibig sabihin meron change na 5 degrees Celsius ha. So let's say 5 degrees Celsius. And then another one. Sir, try natin 10 degrees Celsius. Wait lang. Sir, yung cake ba na yun ay isa lang? Siyempre hindi. Every runs or every experiment mo, ibang cake na. Pero, dapat parehong cake lang yan ha. Pareho yung klase, pareho yung paggawa. I mean, identical cake. Okay, dapat fresh din. Fresh. And then, let's say, lastly, sir, consider natin na 5 degrees Celsius. And then, biglang ganito yung line. Okay? So, dun nyo na malalaman na, wow, ibig sabihin, nakikita talaga natin, sir. Nagbabago yung line kapag nagbabago yung temperature. So, ibig sabihin, sir, mas nagiging constant ito kasi hindi siya masyado nagbabago. Ito, nagde-degrade siya, sir, oh, bumababa yung quality. Ito, continuous lang yung quality niya, sir, oh. So, ibig sabihin, sir, okay yung 5 degrees Celsius. Now, yes, you can also make a statistical analysis wherein you're going to compare all of this. Okay, going to compare all of this graphs or lines. And then you can make a conclusion na okay, regardless of the temperature here, the expected average shelf life of a cake regardless of the temperature is, let's say, the shelf life is t is equals to 8.5 days. So that's the data. So conclusion, yes, that's the data. Now, what's the problem? The problem is that we don't really know for sure. The problem is that we humans don't really know for sure the shelf life of the cake. That's why if we're going to exceed the average shelf life or the shelf life of a cake, you can lead to poisoning. So that's a problem. You want to solve the problem of poisoning in cakes. Poisoning by by telling the people na, okay, this cake has only a shelf value inside the refrigerator of 8.5 days. Okay? So that's how you do it. So in design experiments, you eliminate all the you eliminate all the possible sources of variability, and you're going to control only one. You're going to control only specific variables. In this case, sa cake sa loob ng ref, you only control the temperature. Control yung temperature. So that's how you do design experiments. And later on, in the last part of the of EDA, you're going to have an experiment more on engineering, more on analysis of variance and then design of experiments. So, bakit magkasama yan? Kasi you use design of experiments. One of the statistical use that you use for design of experiments is analysis of variance. So that's it. So I hope this clears out your I hope this already entices you of what's we're going to learn about more on statistical analysis, specifically engineering data analysis. Okay, so signing out.